Hello, sixth graders. Mrs. Parsons here, and it's time for another mathematics video coming to you straight from West Platte Elementary School. I always feel like I should be an announcer when I'm doing these. And ladies and gentlemen, this evening, your category will be on decimal division. We will be discussing, I'll stop that. Serious now. Sixth graders, good afternoon, good morning, good evening, whenever you're watching this. This is Mrs. P, and we are going to have another mathematics video on decimal division. And what I'd like to discuss with you today is how we look at dividing whole numbers by other whole numbers that turn into decimals, or decimals that are divided by whole numbers when we have decimals already in what we call our dividend. So I want to talk to you about these two things because I want to make sure you, again, I gave a video the other day about decimal division. And really, I started off with just a video on long division. And I really want to make sure you understand how long division works, because if we have a good understanding about how long division works, then we'll be able to do division with decimals, because nothing really changes except that thing called a decimal. The division itself, how you divide the numbers and the quotient that you get at the top of the division house, is going to stay the same. The thing that changes is where you put that decimal. Where is the decimal located? What holes do I have? What parts do I have? Do I have any of either one of those things? So I'm going to do a problem that we did in class today with all the sixth graders here. And I'm going to make it go from looking like it's whole numbers divided by whole numbers into it turning into a decimal. And what you guys would typically do is when you finish division, if there's anything left that you can't divide, you say it's remainder. Well, in sixth grade, we're no longer going to put it up there by the division house and say it's a remainder. Instead, we're going to continue that division problem on, and we're going to take those into parts by adding a decimal. So here's the example what I did in class today just for you. So I asked the kids for a number, a two-digit number, and one of the students gave me 20. And then I asked one of the students for a five-digit number, and they gave me 22,586. And now, sixth graders, we want to divide this. And if you look at it, it looks like a pretty standard long division problem, whole number by whole number. But I want to show you how that changes and then what you need to do about it. And then I want to show you another problem that already has a decimal in it. And hopefully it'll be a short video, but just bear with me, okay? So when we have a problem like this, sixth graders, the first thing we're going to think is that it's just long division. I'm just going to divide this problem. I'm going to take this divisor. We know this is the divisor, what you're dividing into it, okay? This is the dividend. This is what you're dividing into. This is what you're using to divide. This is what you're dividing into. And if you remember my first video on long division, we talked about this all being related to place value. I need to see how many 20s I can get out of 22,586. And I teased the kids and said, think about you go and buy a lottery ticket and it costs you $20. And you win $22,586. I wonder how many $20 lottery tickets I could have bought with that money. So that's what we're looking at. We're looking at how many times this 20 will go into 22,586. And if, as I said, you remember the long division video, we look at this whole number, and it's a nice, pretty number. We don't even need to use a compatible number, something that we like better that's closely related to it, because 20 is a really pretty number. It's got a 0 in it. So the first thing we do is we look at the first place value that's in our dividend. And in this case, it's a 2. And that 2 is in the 10,000th spot. It's in the 10,000 spot. And what that's asking us or telling us is saying, hey, is there a certain number that's in the 10,000 spot? And this is what it would look like. That if I multiply 20 by it, I would get back 22,586. And sixth graders, if you had a number that was larger than 10,000, you couldn't multiply it by 20. Because if you did, you would get a number much larger than the 10,000 spot. So what that tells us is that we will not have a number above the 2 in the 10,000 spot. Because 20, I can't multiply it by something in the 10,000 and still only get 20,000 back. And I want to show you what I mean. I'm just going to cover over this. If this was 10,000, sixth graders, we know that if we multiply it, these are all going to be zeros. 1, 2, 3, 4, 5 zeros. I now am going to go over to my next place value, which is 2. I'm going to add my placeholder, and then I'm going to multiply again. Well, I know that's 0, 0, 0, 0. So I'm going to add 4 more zeros. 1, 2, 3, 4. And I know that 2 times 1 is 2. And when I add that all up, sixth graders, it's 200,000. So 20 can't be multiplied by anything with the number 10,000 in it, because it would give me back too big of a number that I know that 22,586 would not be the actual dividend I would get back. So we know it's not going to be in the 10,000s. So since it won't go into that 2, which is in the place of the 10,000s, we're now going to look at these two numbers up front and their place value, which is now the thousands position. And what that is asking us is, can I multiply something by 1,000? Or can I multiply 20 by something in the 1,000 spot that will get me back 20,000? And again, if I cover over that, even if I just said this was 1,000, sixth graders, again, these are all zeros. I'm going to add my placeholder. That's 1, 2, 3 more zeros. And 2 times 1 is still 2. I add them up. That's a terrible 0. Sorry about that, sixth graders. And I get 20,000. So the first place I'm going to put a number at in my quotient is in the 1,000 spot. 10,000 is too big. 2,000, the 1,000 spot will work perfectly. So we ask ourselves then, 20 into 22, how many times? Goes once. 1 times 20, because we know we're going to do division, multiplication, subtraction, bring down, and repeat. So we're going to do this process for long division, and it's been that way forever and ever and ever and ever. Now, Miss P's going to scoot this back just a smidgen. There you go. And so I've done the division. I know 20 will go into 22 once. I'm going to multiply now. 20 times 1, which is 20. I'm going to subtract that 20 from the 22, and I'm going to get left 2. And I'm going to bring down my next place value, which is 5. So now I'm looking at 20 into 25, which means, can I multiply 20 by some hundreds and get that to work when I can do that division? And of course, when you look at this, you know that 20 will go in the 25 one time. And 1 times 20 again is 20. I then subtract. I get 5. And I bring down and repeat. Bring down the 8. I ask myself, 20 into 58. 20 will go into 58 twice, which is 2 times 20, which is 40. I have 8 left. Oops, I have 18 left, sorry. And I bring down my 6. And then I ask myself, will 20, and I wish I could make this board smaller, will 20 go into 186? And this is back to compatible numbers. Do you know anything times 2 that might give me a 1/8 at the front of it? Well, hopefully, sixth graders, you know 2 times 9 is 18. So the best number for me to start with in my quotient is 9. Because 9 times 2 is 18. So 9 times 20 must be 180. I take away 180, and I'm left with 6. Now, sixth graders, if you notice, there's nothing left to bring down now. But I'm still left with 6. This is because, sixth graders, this division problem doesn't terminate. It doesn't stop. If it stops, it would have a 0 there. But since it doesn't stop, instead of now doing what you guys used to call remainders, usually you would come up here and say remainder 6. We're not going to do that any longer in the 6th grade. We actually want to see how many parts we have. So instead, what we're going to do is we're going to add a decimal at the end of that number, and we're going to bring it up into my quotient, and we're going to add an extra 0 so that we can keep going on. And when I add the 0, I then just bring it down, and I add it to my 6. I then ask myself, how many times will 20 go into 60? And hopefully you're going to tell me 20 times 3 is 60. So I come back down here, and 60 minus 60 is 0. And now my division problem has stopped. And that's called a terminating decimal. Terminating decimal. That means, 6th graders, that my division comes to a 0. I've stopped. I've went as far as I can go. I know my answer must be 1,129 and 3/10. And now I've completed my long division problem. And I can even check to see if I'm right. I can then go back and say 1,129 and 3/10 times 20. And I just line up the numbers times 20. Because in this problem, 6th graders, it said that 20 would go into 22,586. It would go in there 1,129 and 3/10 of a time. So I'm going to take my divisor. I'm going to multiply it by my quotient. And if I'm right, I should get back my dividend. Let's see if we do. These are all going to be zeros, right? Anything times 0 is 0. There's 5 of them. I've now used that 0, so I'm going to go over to the next place value. I'm going to add a placeholder, and then I'm going to multiply just like I multiply any other numbers in life. 2 times 3 is 6. 2 times 9 is 8. 2 times 9 is 18. Put my 8 down, carry my 1. 2 times 2 is 4. Plus the 1 I regrouped is 5. 2 times 1 is 2. 2 times 1 again is 2. And then I'm going to add these up. And 6th graders, when I add them up and I count my decimals, I've got I've got 1 decimal. I've got 1 place behind it. I come to my answer, my product. I put my decimal at the end. I move it over once, and I get an answer of 22,586. And that way, I know I'm absolutely right. But 6th graders, the big important thing I want you to remember is look at the place values. You're asking yourself, can I multiply 10,000 times 20 and still get back 22,586? And I can't do that. So I know I'm not going to put any number right there. I then go to the next place value and use the first 2 numbers. 22. Can I multiply the 1,000 number by 20 and get something back like 22,000? And we said we could. We said we could do it once. This is what we call the standard algorithm in mathematics. Okay, 6th graders? This is called the standard algorithm in mathematics for long division. We want to divide our divisor. So we have a divisor on the outside. We have a dividend on the inside. And we want to take that dividend and we want to divide our divisor into it. Once we find out how many times that divisor will go into our dividend place values, We then multiply. We bring that down and multiply. We then subtract that multiplication from our place values. We then bring down the next place value in our dividend. And we just keep repeating it until it stops. Okay? Until we get to 0. So then, 6th graders, that shows you a problem that starts out as whole numbers, ends up in a decimal. I want to do a problem for you right now, 6th graders, last thing on the video, that is a division problem that already has a decimal in it. I'm going to grab it really quick. Let me grab it. I saved it for myself. Oops, now this one. Nope, not this one. I'm going to do a different one. I want to do this problem that already has a decimal in it. So it's really quick and easy one. I'm going to take the number 25, and I want to see if it'll go into 11 and 75 hundredths. Now, I'm going to imagine, 6th graders, you're already seeing this. And if you're thinking about money, you're already going, oh, wait, Mrs. Parsons. If that's 25, that ends in a 5. 25 should go into that. But what you want to remember, if you look at this like it's $11.75, and you want to give that $11.75 to 25 of your friends, you want to see how much you're going to give to those 25 friends. There's no decimal out here. It's just the number 25 friends. My friends don't have a decimal in it. If there is not a decimal in your divisor, 6th graders, you just bring up the decimal from your dividend and put it into your quotient. There's no decimal out here. So all I want to see is how many 25 wholes can I get out of this decimal. So if there's a decimal in my dividend, I just bring it up and then I just divide like normal. 25 won't go into 1. 25, it won't go into 11. So I have to take 25 into 117. Now, I'm going to imagine you guys are already thinking 25, 25, 25, 20. 4 quarters make $1, Mrs. P. So you're going to tell me that 25 will go into 117 4 times. Because you know 25 times 4 is 100. So I divided 25 into my place value. That would work. It wouldn't work here in the tens. It wouldn't work here in the ones. But it would work in the tenths. So I went all the way over to these 3 and divided. Then I multiplied 25 times 4, which is 100. I'm now going to subtract, and that leaves me 7. I'm now going to bring down my last place value, which is a 5. And I'm going to repeat. I'm going to see if I can take 25 into 175. Now, most of you are going to tell me again, 4 quarters make $1. There will be 3 more quarters that will make up 75. So I think you're going to tell me, Mrs. P, 25 will go into 175 7 times. So I put my 7 up there, and then I multiply. 7 times 5 is 35. I regroup my little 3 up there. 7 times 2 is 14. Plus 3, ladies and gentlemen, is 17. I subtract, and I'm left with 0, which means my answer is done. And I can check myself. 25 times 0.47. I take my divisor and I multiply it by my quotient. 7 times 5 is 35. Carry my 3 or regroup my 3. 7 times 2 is 14. Plus 3 is 17. Add a 0 for my placeholder. 4 times 5 is 20. Regroup my 2. 4 times 2 is 8. Plus 2 is 10. And I add them all up. 5, 7, 1, 1. I look for my decimals. There's only 1 in my problem. I start at the back and I move it over 1, 2 places because there's 2 places behind the decimal. So 6th graders, that's showing you how you take whole number division and it creates a decimal, no remainders, and how you do it if there's a decimal already in the problem. If there's a decimal in your dividend, just move it up into your quotient and divide like usual. As always, questions, send them my way. I'll help you as much as I can, sixth graders. A little bit longer video tonight, but I really want to make sure you understand that. Again, if you're feeling like you're a partial quotient person, where you break it up, send Mrs. P a message and I'll make a video just for you. Until then, have a great morning, afternoon, or night, and I'll see you back here for the next Mathmania, Mrs. P's mathematics videos. See you later, sixth graders.